Hey guys, it's Miss Miklos, and in today's lecture, we are going to be talking about right triangles and actually solving right triangles, which will eventually lead us into doing some word problems. So first of all, I just want to let you guys know there is a note handout for today that has all the word problems typed out. However, we are going to be doing some problems that aren't on that. So let's start with just solving. So the directions are going to state solve the triangle, and it's going to give us information. In this case, it gives us an angle and a side. So whenever I see this, the first piece of information, or the first thing I'm going to do actually, is draw out a triangle. And I know that this is angle C and our hypotenuse is side C, but the other angles, it really doesn't matter where I put them, okay? You could either put angle A here or put angle A there. What is important, though, if this is angle A, then straight across from it needs to be side A. If this is angle A, then straight across from it needs to be side A. So I'm just going to put A here and B here, which makes our sides A and B respectively. So if I fill in my given info, I know that this is going to be 20 degrees and this side is going to be 10. So looking around, I'm just going to make a little note for us. We know C is 90 degrees. We also need to find side A, side C, and angle B. And I'm going to start here by finding angle B. We know that since all three angles add up to be 180, the acute angles are complement, which we know means that they equal 90 degrees. Okay, so if I'm adding this, 20 plus what would equal 90? And I know that this would have to be 70 degrees. So I'm going to go ahead and say that B is 70 degrees. So that's information that we can figure out without using trigonometry at all. Now we need to determine, do we want to find side A or side C? And it really doesn't matter. I'm going to start with side A. And the thing I want to stress about our lesson today is that when we're solving a triangle like this, there are multiple ways that we can do it correctly. So I'm going to start with an angle, and I'm going to use angle A. The reason why I'm choosing angle A is because 20 degrees was given to me, so I know that that is accurate. Now technically, if I use angle B, if I did all my work right, this should give us accurate answers as well. But I don't know about you guys, but sometimes I do dumb things and I subtract or add incorrectly. So that's why for me, I always like to go off the given info whenever possible. So I'm going to use 20 degrees. And I noticed here that if I'm trying to find side A, that would be the opposite side. And side B is what we're given, and that is the adjacent side. And I remember that tangent deals with opposite and adjacent. So I'm going to say tan of 20 degrees equals A over 10. So in order to get A all by itself, I'm going to multiply both sides by 10. And I always like to put this 10 as the coefficient, so that way when I put it into my calculator, it doesn't get messed up depending on my parentheses. I can just type in 10 tan of 20. Now, I just want to make a quick note that we have a degree symbol, so I need to make sure that my calculator is in degree mode. And when I type in 10 tan of 20 degrees, I end up getting that A is 3.6. So I'm going to go ahead and write 3.6 up here. Now, the final thing we have to find is side C, and there's actually two different ways that we can do it. So the first method is we could use Pythagorean theorem and do 10 squared plus 3.6 squared equals C squared. And when we do this, I end up getting 10.6 is our C value. So I'm going to go ahead and write 10.6 up here. The other way that we could have done it, we could have used another trig function. For example, I could have done cosine of 20 degrees, that 2 is kind of weird there, is equal to the adjacent over the hypotenuse, so 10 over C. And this is a good way just to practice how do we isolate something if it's in the denominator. So I'm going to multiply both sides by C. So C times the cosine of 20 degrees equals 10. and then divide both sides by the cosine of 20 degrees. And if you guys put this into your calculator, amazingly, we happen to get 10.6. If we look at this triangle, our answers do make sense because we know that the biggest side should always be across from the biggest angle. So it makes sense that B is bigger than A as well. Okay, we're just going to do one more of these before we get into our word problems. And on number 2, we are given 2 different sides. So I'm going to go ahead and label this A and this side B. So I'm going to say 12 and 15. That is angle C. So the first thing that I'm going to do, I need to find what side C is. So I'm going to use Pythagorean theorem and say 12 squared plus 15 squared equals C squared. And so as I'm going through this, I end up getting that 19.2 is equal to C. So that is our first answer. Now we need to determine which of these 2 angles do we need to find first, because those are the only 2 things we need to find, because we know that angle C is 90 degrees. I'm going to start with A, and in starting with A, once again, this is an example where I'm going to use the given information. I'm going to use 12 and 15. So that looks like the opposite side and the adjacent side, so I'm going to say tangent of angle A is equal to 12 over 15. We know that to find an angle, I'm using tan inverse. So I'm going to do tan inverse of 12 divided by 15. So make sure that when we're doing this, we know that we should be in degree mode. And that's something we should always check as soon as we start our assignment. Okay, and this would be 38.7 degrees. And that is equal to A. Now the good news is I do not need to go through that whole process again for B, because I know that angle B is just going to be 90 minus 38.7 degrees, because we learned that those acute angles are complementary. So I'm going to go ahead and do 90 minus that answer, and I get that B is 51.3 degrees. So the key thing on these triangles is there is more than one correct way to go about doing them. I just need to make sure that my trig ratios are correct in regards to whichever one I end up using, and that I'm rounding correctly and all of that. Okay, so our first word problem says find the height of the building if it casts a shadow of 210 feet when the angle of elevation to the sun is 52 degrees. And I want to start here by talking about this term angle of elevation. Okay, last year in Algebra 2, you guys learned about 2 specific types of angles. An angle of elevation and an angle of depression. With an angle of elevation, we draw our triangle out and up. Okay, and this angle of elevation is this angle that is created from going out and up. An angle of depression is what is formed when we go out and down. So we can see that an angle of depression forms a completely different shape of a triangle. So it's important that we know what these 2 different terms mean. Okay, so now back to the problem at hand. It says find the height of a building if it casts a shadow of 210 feet when the angle of elevation to the sun is 52 degrees. We know that we should always draw a picture when we see a word problem, and specifically today, our picture should form a triangle. So some of you guys are like amazing artists, and others of you have been blessed by the Lord with gifts elsewhere, and that camp would include me. And the whole point is it doesn't matter if I'm a good artist or a bad artist. I really need to be drawing a triangle in some way. So I'm going to start here by drawing some sort of building. So here is my building. There we go. I'm struggling finding a color here. And it says that it casts a shadow. We know a shadow goes along the ground. That was an awful line. My stylus slipped. Okay, and then it talks about the angle of elevation to the sun. So we have a sun that is up here. There we go, it's shining down. And it tells us that this angle of elevation is 52 degrees. It also tells me that the shadow is 210 feet. I know that this forms a right triangle because everything we're doing this chapter forms a right triangle. And the thing that I like about our word problems is that rather than finding everything in the problem, I just need to find one side. In this case, it asks us to find the height of the building. I'm going to call that H. So if I look at this, we're talking about the opposite and the adjacent. So I'm going to say tangent of 52 degrees is equal to h over 210. So I'm going to multiply both sides by 210. And when I put that into my calculator here, I end up getting 268.8 feet. So we are always going to round to the nearest tenth. Okay, so number 2 says find the angle of depression from the top of a lighthouse 250 feet above the water level to the waterline of a ship 2 miles offshore. So I'm going to start here by drawing out what this picture looks like. Okay, so I have my beautiful lighthouse. I know you wish you were as talented as I am. And then we have our water level and we have our ship. The key word here, angle of depression, tells me that my triangle needs to look a little bit different. So it needs to go out and down. Okay, so this is the angle of depression that we are trying to find. Now it tells me that the lighthouse is 250 feet, but notice the lighthouse is not part of this triangle. However, I can see that this opposite side is the same height as our lighthouse. It also tells me that the ship is 2 miles offshore. I know this water distance is the same as the top of this triangle. And something kind of weird happens if I just say 2 miles, because these are not in scale with one another. We do need to convert. And so we know that 1 mile is equal to 5,280 feet. So this becomes 10,560 feet. So if I'm trying to find this angle, I know the opposite and the hypotenuse, so I'm going to say tangent of theta equals 250 over 10,560. And before we even get going here, I'm thinking that this angle is going to be super, super small because this side is way smaller than this side is. So in my calculator, I'm doing tan inverse 250 over 10,560, and I end up getting that theta is 1.4 degrees, which often I would think is a mistake, but in context of this triangle, that answer actually makes sense. From a point 100 feet in front of a public library, the angles of elevation to the base of a flagpole and the top of a flagpole are 28 degrees and 39.4 degrees. Find the height of the flagpole. So first thing we're going to do is draw a picture. And the fact that they're telling me that we have 2 different angles of elevation is a sign that we're probably going to have 2 different triangles here. Okay, so I went ahead and just found a picture here. So we're saying that we are 100 feet away. And the angle of elevation to the base is going to be 28 degrees. And the angle of elevation to the top is 39.4 degrees. And so in looking at this, okay, what gets kind of tough here is the height of the flag, I'm going to call that F. I notice that that's not actually a side in my right triangle. However, if I find this opposite side and this opposite side and subtract them, we will end up with the height of the flag. So I'm going to call this whole thing X and this part Y. So it looks like once again we're using tangent, so I'm going to say tangent of 28 degrees equals x over 100. So in my calculator, I'm doing 100 times the tan of 28 degrees, and I end up getting that this is 53.2. My other triangle, I'm going to do tan of 39.4 degrees equals y over 100. Oh shoot, I messed up these, sorry. I can't even read my own writing. Okay, sorry, this was y, just depending on how I actually drew out my triangles there. Okay, then this is x. So I get 100 times the tan of 39.4 equals x. And when I put that in, I get 82.1 equals x. So I'm going to do x minus y here, so 82.1 minus 53.2 gives me a height of 28.9 feet. So this is a good example of just a tougher problem because it's showing us that sometimes we have to use more than one triangle to get the right answer. A 45-foot ladder leans against the side of a building. So I'm going to just go ahead and draw a building here. And it says the ladder's leaning against it. So there's my ladder. And it's 45 feet. It tells us what should the angle between the ladder and the ground, so that's what I'm trying to find, be in order for the ladder to reach up 36 feet on the side of the building. So this is 36 feet. So this time, in reference to our angle that we're trying to find, we have the opposite and the hypotenuse, so I'm going to use sine. So sine of theta equals 36 over 45. So in my calculator, I'm going to do sine inverse, 36 divided by 45, and I get that theta equals 53.1 degrees. When an airplane leaves the runway, its angle of climb is 18 degrees and its speed is 275 feet per second. Find the plane's altitude after 1 minute. So let's go ahead and draw out this picture. Okay, so this is what our triangle would look like. So the angle of climb is 18 degrees, so that would be this angle down here because that's how high, or the angle, I guess I should say, that the airplane is taking. We're trying to find the altitude, so I'm going to label this A. And it says that the speed is 275 feet per second. So I know that they are traveling across the hypotenuse at 275 feet per second. We're trying to find the altitude after 1 minute, so I'm going to have to figure out what is 275 times 60, because I know that there are 60 seconds in 1 minute. And I get 16,500. So now that I've figured out that part, and that was the difficult portion of this problem, I know I have the opposite and the hypotenuse, so I'm going to use sine. So sine of 18 degrees equals A over 16,500. So in my calculator, I'm doing 16,500 sine of 18 degrees. And when I put this in, I get 5,098.8 feet. Number 6 is a little bit tougher. It says, given a cube with an edge of 10 centimeters, determine the angle between the diagonal of the cube and the diagonal of the base. So the first thing that I'm going to do here is go ahead and draw out a cube. Okay, and the stuff that it's asking me, okay, it's really talking about the angle between the diagonal of the cube and the diagonal of its base. Okay, so the diagonal of the base is going to be right here. And the diagonal of the cube would go from this top to this top. So this is my triangle that is drawn out of that. So I'm going to go ahead and just kind of redraw that out here. So I know that this is 10 centimeters because it is one of the edges, because that is that side right here. Now with this length, okay, this is going to be this side right here. Let's just take a look at this for a moment. Okay, once again, this forms a right triangle, even though it doesn't really look like that because it is in 3 dimensions. And I know this is 10 and 10. If we did Pythagorean theorem, we would get that this side is 10 radical 2. So I'm going to go ahead and write that that is 10 radical 2. And we are trying to find the angle formed between this diagonal and this diagonal, which would be right here. So it looks like the difficult part in this problem was setting that up and understanding what information it was talking about. I know we're going to use tangent because it's talking about the opposite and the adjacent. So in my calculator, I'm going to do tan inverse of 10 over 10 root 2. And I end up getting that theta equals 35.3 degrees. Number 7 is another tough one. It says a road sign at the top of a mountain indicates that for the next 4 miles, the grade is 12%. Find the change in elevation for a car descending the mountain. So the very first thing I'm just going to draw a triangle for this one. Okay, some things that they're telling us that we're trying to go ahead and find the change in elevation. So that's going to be my x. And it's for the next 4 miles. So my horizontal part is going to be 4 miles. And the problem that we have is I don't really know what this angle is. But I noticed that they give us a 12%. So what we can actually do with that 12%, that tells me that we are going down 12 for every 100 feet. And we can use that value to find the tangent of an angle. So tan of theta equals 12 over 100. So when I put that into my calculator, I get theta equals 6.8%. So I'm going to go ahead and put 6.8% in there. And at this point, this problem now becomes very simple because we're talking about opposite and hypotenuse. So I'm going to say the tangent of 6.8 equals x over 4. So 4 times the tangent of 6.8 degrees equals x. And I get 0.47 miles is equal to our x value. Number 8 says a passenger in an airplane flying at an altitude of I wrote mics. It should be miles. Sees 2 towns and notes that the angles of depression to the 2 towns are 55 degrees and 28 degrees. How far apart are the towns? And there are actually 2 different ways we could do this problem, so I'm going to do it twice. The first way is if one of the towns was to the left and the other town is to the right. Okay, and our angles of depression were 28 degrees and 55 degrees. And we know that this is 6 miles, or 6 mics as I like to call it apparently. And we can call these 2 distances x and y. So I know that the total distance is going to happen when I add x and y together. So here's our town, and this distance here is x plus y. So this is really similar to that library problem where we're going to use these 2 different triangles and do something with it. So in both of these, we're talking about the opposite and the adjacent. So I'm going to say tan of 28 degrees equals 6 over x. So I end up getting x equals 6 divided by the tan of 28 degrees, which ends up being 11.6 miles. I also have the tangent of 55 degrees equals 6 over y. So when I do y equals 6 divided by the tan of 55 degrees, I end up getting that y is 4.2. So when I add those two values together, I get 15.8 miles. Now, as I was saying, this is not the only way we could have thought about it. What if the plane had seen the two towns on the same side? Okay, so this is a town and this is a town. This time, okay, if this was 28 degrees and this whole thing was 55 degrees, I'm going to call this X and this whole thing Y. This time to find the distance here, I would need to do Y minus X. Okay, and when I subtract those values that we already found, I would get 7.4 miles because that is 11.6 minus 4.2. Those trig ratios end up being the same because this is still 6 miles. Okay, so I just want to point out that on a problem like this, if we're not given more information, there are legitimately two different ways we could find it. So I just want to stress that we went through some tougher problems on here. There's definitely going to be some easier problems like number 1 and number 4, but I would also expect to be able to do a tougher problem.